Video going. During a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. Jackie skates for 5 meters and Peter skates for 7 meters. How far apart are the skaters? So they start in the middle. One of them goes 5, the other one goes 7. It's a, I wrote another 5 there, strange. 7, they're 15 degrees between them. And when it says how far apart are the skaters, they're talking about this is a skater, this is a skater. How far is that? So, obviously you have the exact same picture already drawn for you. How are we gonna approach this? Is it a law of sines? Is it a law of cosines? Is it an area? It's definitely not an area. Law of sines or law of cosines? Do we have any matches? No, no, no. Which means it's time for law of cosines. And we're looking for a side. So we're gonna use the c squared equals a squared plus b squared minus 2ab cosine c. Plug everything in. C squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine 15. Don't forget that once you get an answer, you'll need to square it. Square root it. Too many mistakes in a row. Wake up. I got a number that's less than 5. Yep.
I'm sorry.
That's okay.
The classroom. Wait.
What? This happened earlier. Somebody already did this. You got it?
I think this used to be his.
Oh, I see what you're saying. You're all good. Don't worry about it. I think we're just ranked. I don't know what's going on. Okay. C is equal to 2.52. 2.53, I guess, if we round it up. It doesn't say how much we need to round, so maybe 2.5 is good enough. And let's put a meters on the end of that. Does that feel okay? All right. Question number 2. How about for question number 2, we don't solve it, we just decide which formula we want to use. A bridge is supported by triangular braces. Okay, so if I think of a bridge, maybe it's like this. If the sides of each brace have this length of 63, 46, and 40, find the measure of the angle opposite the 46-foot side. I don't really know that the bridge part is really that interesting. All I know is we got a triangle with these 3 sides, and we're trying to find the angle. What do we think? Are we doing, I think we need to do cosine, because we got 3 sides and we're talking about an angle here. So if we do cosine for this, we're looking for whatever that angle is. Again, there's kind of those 2 optional formulas, maybe the one you have memorized or maybe the one that's given to you on the test. If I go to use this one that's on the test here, I want to make sure that cosine C, it should be minus C squared, which is this one, 46. Everything else is going to be positive, so everything else is kind of okay. It says a squared, maybe that's 40 squared plus 63 squared on the bottom. 2 times 40 times 63. I guess I said we didn't need to solve this one, but we're pretty much already there. Second cosine alpha y equals enter 40 squared plus 63 squared minus 46 squared on the bottom. 2 times 40 times 63. Enter. I got theta is equal to 46.75, and we'll make that 0.8 degrees. Interesting, right? A side of 46 and an angle of 46. How interesting. Let's see here. Two observers standing on shore, half a mile apart. A and B measure angles at that time. Honestly, 3 is great. Let's move on. When I see question number 4, looks a little bit more complicated to me. I don't know that I'm getting this. I like the picture. Whoever did it is a real artist. A vertical flagpole is attached to the top edge of a building. A man stands 400 feet from the base of the building. From his viewpoint, the angle of elevation to the bottom of the flagpole is 60. To the top is 62.5. Find the height of the flagpole. So let's try to get all these numbers on there. The first is 400. Where does 400 go?
Did you draw the picture?
I did not. 400 feet from the base of the building. I think that this, oh, not that. I think that this is 400. Okay? The next is, from his viewpoint, the angle of elevation to the bottom of the flagpole is 60 degrees. Where does that 60 go? It's gonna go here in the right triangle, the bottom piece, because it says that the angle of elevation to the bottom of the flagpole is 60. The angle of elevation to the top of the flagpole, it says 62.5. So what is the tiny little angle right here?
62.5.
2.5.
So, we've got this kind of shape, right? This one is 60, and this one is 62.5. Does that mean that this is 60 and this is 62.5?
Sounds about right.
No, because that would be 120, which means he would be looking like that.
So is it 2.5?
It is only the difference, nice job, of 2.5. So this little bit here is 2.5. And they want to know the height of the flagpole. The height of the flagpole. Well, in order to do this, we need a little bit of information. And whenever you have two shapes that are touching, you always want to think about which side are they sharing, and can we kind of work in the wrong shape first and then make our way over to the correct shape. This is our goal. And that is on our oblique triangle. This down here is a right triangle, and honestly, it's not very useful, but what we're gonna do is try to work in that right triangle, and then accidentally later on, figure out the oblique triangle. So if we work in our right triangle, which is 400 on the bottom, 60 degrees right there, we have enough information to figure out the rest of this triangle because we know that it is a right triangle. And so we know that it's 60 and 90. Can we figure out the other side, the other angle, I mean? Should be 30, right? Because a 30, 60, 90 triangle is one that we've kind of memorized. It sounds good. We also could use our boring old SOHCAHTOA to figure out the sides of this triangle. Now, I don't think that finding the height of the building is very useful, okay? It doesn't really affect the height of the flagpole, but I do think that if we find the distance here, that is pretty useful because that is a piece of our oblique triangle. So I think that if we learn this side length, it would help us move forward in the question. In order to do that, we want to think about SOHCAHTOA. We know the angle, we know the bottom. Would you call this opposite, adjacent, or hypotenuse? This is adjacent because it is next to 60. And then what would you call this? Opposite, adjacent, or hypotenuse? Hypotenuse. And so if it has adjacent and hypotenuse, which one are we going to use? Cosine. All right, so the cosine of 60 is equal to adjacent over hypotenuse, and we know that the adjacent is 400. We want to try to solve for that h. If we solve for h, maybe we do a times h and a times h to bring the h over to the other side. And then how do we get the h away from the cosine 60? We would want to do a divide. H equals 400 cosine 60. We actually know what the cosine of 60 is because we're unit circle masters. Remember that? Cosine of 60? It is 1/2, Smarty. And when I type all this in, I get that h equals 800. Now 800 is not the answer to the question, but 800 is getting us in the right direction. We know that it's 400 on the bottom. Honestly, I think we've kind of used that information. I don't know if we're going to be reusing 400, but we do know now that 800 is this. We know that 2.5 is this tiny little angle here. Our goal is to figure out the height of this flagpole. In order to do things in a oblique triangle, you have to have 3 pieces of information, and we only have 2. We've got the 800 and the 2.5 degrees. We've got to find one more piece of this triangle before we can do anything. We don't really have any tricks, except for that a triangle adds up to make 180. But that also doesn't really help us because all we know is 2.5. There's one more trick up our sleeve that we've used. We know that this is 60 and this is 30. And if that is 30, we should be able to figure out this angle as well. That would have to be 150. That's using our knowledge of supplementary angles or linear angles. And so now we've got it, okay? Now we've got an oblique triangle with 800 as a side, 150 as an angle, and 2.5 as an angle. We want to figure out this side. Can we do law of sines? 150 degrees, no match. 2.5, no match. 800, no match. But before we rush into the law of cosines, I think we could figure out the match for 800 here. Exactly, 180 minus 150 minus 2.5, 27.5. And so of course, you could have used the law of cosines if that's how you like it, but I'd rather do the law of sines. Now we have a match. We're going to be looking for the one that matches up with 2.5. And so the sine of 27.5 over 800 is going to be equal to the sine of 2.5 over x. That's what we want. Do a little bit of algebra. Cross multiply. X sine 27.5 equals 800 sine 2.5. Divide by sine. X equals 800 sine 2.5 over sine 27.5. We go to the calculator. 800 sine 2.5 divided by sine 27.5. And after all of our hard work, how tall is the flagpole? I think I heard somebody do the weird wheezing speak and they said it. 75.57, maybe we'll make it 75.6, which is pretty dang tall for a flagpole, if I do say so myself. 7-story tall flagpole, but I guess they do exist out there. If we wanted to be teacher's pet and find feet, we could put it on. All right. Honestly, do I expect to have a question like this on the test? Not really. But this question is pushing us to our limits of what we kind of know how to do. Remember, if you're ever doing a question with 2 triangles, with 2 anything, it's almost always a good strategy to figure out what you're looking for and then go to the other shape because the math teacher probably wants you to have to go a little bit out of the way before you go back and find what you want. So we started with the right triangle where we're a bit stronger, and then we went to the oblique triangle. Okay, we've been doing this for a bit. I've been talking a whole lot today. We got 3 questions on the back. Why don't we pick 1 and then we're done for the day.
7.
I heard 7. Anybody want to second that?
Sure, one second.
All right. Fire towers A and B are located 10 miles apart. Thank God we only have 1 triangle. This should be so much easier. Rangers at fire tower A spot a fire 42 degrees, and rangers at fire tower B spot the same fire at 64 degrees. How far from tower A is the fire to the nearest 1/10 of a mile? Well, looks like here we have angle, side, angle. 2 angles and a side. Now that should give us the possibility to use the law of sine, although we could go for cosine if you really wanted to. In order to use the law of sines, we're going to need matchings, and right now we don't have any matches, but we have 2 angles, so we should be able to find the third. 180 minus 42 minus 64. I'm getting 74 as our last angle. Now I have a nice match. The sine 74 divided by 10. And let's make sure we set this up and find what we want. How far is tower A? Now, if we use our letters here, and I put a little baby A over here and a little baby B over here, are we trying to find side A or are we trying to find side B?
B.
We're actually looking for side B. And so, we want to go for sine 64 over B. Just like we did before, do some cross multiplying. B sine 74 equals 10 sine 64. Divide that by sine 74. What's up? Yeah, let me get the answer for this and then we go. All right, first one to shout the answer gets plus 2 points on their quiz.
9.4.
It was me.
It was definitely me.
9.4. Nice job. Nice
It was
job.
definitely me.
Definitely.
No.
Not too bad, right?
It wasn't.
I don't know.